Hey everybody, we are ready to jump in here and take we are ready to jump in here and take a look at topic 6 DQ2. All right, so let's move this over just a little bit. Let me get my pencil here ready so we can do some work together and let's see what we've got. All right, first of all, let's read through the question and make sure that we all understand what we need to do here. All right, so the first one, we have 20 horses ran the Kentucky Derby. What do we want to do? We want to find the exacta. What is that? That's the way the first two finishers come in order. We want to find or bet on the first two finishers in the race. All right, that's the first one. Now, does the order matter? Okay, that's the question here. Does order matter? Well, you say it's a race. Of course, order matters. So it does, right? So for the first question, I'm just going to write it right here. This is not a formula. Okay, so order matters here. The next one, we have 20 horses in the race. We want to find the trifecta. That is the way the first three finishers can come in. Once again, it's a race. Order matters, right? Why do I keep saying that? Let's find out as we go. The third one, we're trying to find the superfecta. That is finding the first four finishers. Once again, does order matter? Order matters. It's a horse race. All right. Next one. In a lottery game, 50 numbers of ping pong balls are put in a bin and four are randomly chosen. You win the jackpot. You need to match all four numbers in the order in which they were drawn. All right. Then we want to determine the number of outcomes for picking four different numbers. Okay. So once again, it says order matters. Where did it say that? Right here. The order in which they come. So once again, order matters. All right. Next, a lottery game, 40 numbers of ping pong balls are put in a bin. Five are randomly chosen. To win the jackpot, you need to match all five numbers. Determine the number of outcomes for picking five different numbers. Okay, so you got to match all five. Does it say anything about order? Let's see. You need to match all five numbers, determine the number of possible outcomes. Okay, it doesn't say anything at all about order. You just got to match all five of them. So order doesn't matter. I just put in here no order. Okay, no order. The last one, you have a lottery game. Once again, 40 numbered ping pong balls are put in a bin, five are randomly chosen. You'll get twice your money back if you match three of the five numbers. Still, using this number of outcomes as the game before, determine the probability of matching three numbers out of five. Okay, once again, it doesn't say anything about order. So once again, no order. All right, order is not important. Now, why am I saying order matters or order doesn't matter? Because we use a permutation. Let's scroll back up here just a second. All right, it says you'll be using the permutation for the first four. That is where order does not matter, and a combination for the last two to determine the number of possible outcomes. All right, so let's clear this out. So for the first one I want to use, it said permute. So we're just going to start with the equals. Let's move this palette so I can see the function bar. Here we go. Equals, all right, permute. You see how Excel starts to grab that for me, right, everybody? That says, oh, there's what you want. Yep, there you got it. So permute, click that. It says the number of what? The number n. That is n. All right, let me show you what I'm saying. So I'm looking at per mute, right? N comma R. N is the number I can choose from. R is the number that I'm picking or choosing. Okay. So I'm going to type in N. What is N? There are 20 horses, so that's 20, comma, R. What is R? R is the number I want to choose or pick, and that is 2. All right. So I then close my parentheses, and I get, oh, I got a decimal in here instead of a comma. Okay, sorry about that. There we go. All right, it gives me 380, and I can change the number of decimal places easily enough by simply reducing decimal places if I choose to do so. Okay, you can put it where you want. It doesn't matter. 380 is fine. All right, so that's the first one. I chose permutation because order matters. I chose 20 because that's the number of horses I have to choose from. I chose 2 because that is the number of horses I'm choosing in that order. Okay, let's go to the next to last one. We'll do the last one here. That's fine. Let's do the last. It says the lottery game, once again, there are 40 I'm choosing from, and I'm going to choose 5 randomly. And I want to determine the probability, but this one I have to determine how many ways I can do that. Okay. So how many possible outcomes are there? If I have 40 to choose from and I have 5 to choose, and I'm going to choose 5 of them. Don't worry about any number 3 yet. Don't worry about choosing 3. Look at the total number of possible outcomes. And that is a combination because order does not matter. So that is equals, okay, combination. You can see it popping up here. And there are 40, and I want to choose 5 of them. Okay. And there I go. You can put commas in here if you want to. You can reduce the number. It doesn't matter. Okay. I'm just going to reduce the decimal places, and there I am. All right. 658,008 is the number of ways that I can do this. All right. Fantastic. Now, next, you just keep doing what I've done here. Where I put order, you're going to use a permutation, N, comma, R. Where I put order does not matter. That's the last 2. I'm using a combination, okay? And once again, it says that right here at the top of the screen. All right, next, I want to think about the probability. All right, look at the notes up here. It says, the probability of winning is 1 divided by the number of outcomes for the first 5. Why is that, everybody? Let's think about this. How many ways are there to choose the order in which the first 2 horses come? Well, the only way to choose the first 2 horses in the proper order is 1. There's only one way to choose that, right? Remember, right here, the probability of an event, right here, everybody, in highlighted yellow right here. The probability of an event is the number of favorable outcomes divided by the number of total outcomes. Okay, the number of favorable divided by the number of total outcomes. So the number of favorable is 1. All right, so equals 1. How many favorable outcomes are there for the race? 1 favorable outcome. What is that? I choose both horses in the order correctly. And how many ways could I do that? That would be the cell. Just click on it with my mouse, right? B16, hit enter. And now I have a formula that says 0.26%. Okay, and there I am, good to go. All right. Now, remember it says right here, everybody, the probability of winning is 1 divided by the number of possible outcomes, right, for the first 5. So I'm going to go to the last one. Okay, down to the last one. Right, and the last one, we are doing what? All right, we are going to try to match 3 out of the 5. Okay, so choosing 5 different ping pong balls from 40 is the denominator, and I'm going to determine the probability of matching 3. I'm not trying to match 1. I'm not trying to match 2. I'm trying to match exactly 3 of them, right? That's what I'm trying to match, 3. So the denominator, again, is just the cell right here. What's that cell? That is B21. All right. What's the numerator? The numerator is going to be a combination, everybody. The number of ways is a combination. So one way I could do this, I'm just going to use a C for combination here, okay? So combination, I have 5, and I want to choose, what does it say? I'm going to choose 3 of them, okay? 3 of the 5 numbers. I'm not trying to match 1, not trying to match 2. I'm trying to match 3. How many different ways could I choose 3 out of the 5 correct ones? Okay. But now you got to think about this. Okay. There are also, everybody, there are also some numbers that are left over, right? That I also have to think about and consider. What are those? Well, if there are 40 total, right? 40 total, that means there are 35 that are not winning numbers, right? Not winning numbers. 35 are not winning, but 5 are, and I'm just trying to choose 3 of them. If I have chosen 3 that are correct, that means I could also choose 2 that are not correct, right? 2 that are not correct. It doesn't matter which one they are, right? So that's why I have to use the 5 combination 3. That's the number of ways to correctly choose the three of the 5. They also have to choose 2 that are not correct. How many ways could I choose 2 that are not correct? Okay, and that's the product that we need. This is the fundamental accounting principle. In the fundamental accounting principle, it says the number of ways that something can be done is the number of ways that the first set M could be done multiplied by the number of ways the second N could be done, M times N. In this case, C or C53, the combination 5, 3 is the number of ways I could choose 3 from 5. 35 combination 2 is the number of ways I could choose 2 from the remaining 35. Okay, so let's see about typing this guy in here. All right, equals combination 5, 3. All right, times combination, and what was that combination? It was 35, 2. Close my parentheses, divide by combination, 40, 5. Oops, I got 39. I'm one off here. Let's go back up here and make sure we correct this. I actually don't need to do that. I just need to use my cell to the left, right? Which is what? B21. Okay, and I've got it. So the first 2 is a product combination of the ways I could choose the correct ones, of 3 of the correct ones, and times the number of ways I could not choose the correct ones, and hit enter. All right, and there I go. So the number of ways I could do that gives me a probability of doing that of 0.9. Okay, so is that probable? Not terribly so. Is it more probable than winning the first race? Yeah, it is, according to the percentages giving us there. And that is it, guys. We are all good to go here. Thank you very much, and I will see you guys in the forums. Take care. Bye.